Please don't forget to subscribe our channel for some exciting videos. Hi everyone, welcome back to the channel. If you are interested in shear strength of tape beams, then this video is for you. Today in this video, I am going to show you how we can predict the shear strength of two-span continuous tape beam using artificial neural network. We have developed a computer tool ANN-ConDeep from the final weights and biases of a trained artificial neural network. The neural network was trained on the experimental database of 140 two-span continuous tape beams. These tape beams were subjected to two-point loads at the center of each span. The detailed explanation and the theoretical formulations regarding the development of the neural network and computer tool can be found in the journal paper titled Artificial Neural Network and Associated Computer Tool for Rapid Shear Strength Prediction of Two-Span Continuous Tape Beams. The link to this paper will be provided in the description section once published. Furthermore, we can download this paper from the Regis Research Group website at the University of Toledo. You can go to the publication section here and the link will be provided here once it's published, and you can click the link here and download the paper. To download the computer tool, you can go to this spreadsheet section and use this link to download it. Also, you can download it from this tool section here, from this download spreadsheet button, and yeah, you can download the tool. Now let's look into how we can use ANN-ConDeep. It's very simple to use. It requires 11 input parameters, which are width of the beam, effective depth, shear span, compressive strength of concrete, L strength of longitudinal and transverse reinforcement, longitudinal bottom and top reinforcement ratio, transverse reinforcement ratio, and width of the loading and support plate. All the other properties except this longitudinal top, bottom, and transverse reinforcement ratios can be easily obtained from the drawings, because these are the material properties and the beam dimensions. So let's look into how we can calculate these reinforcement ratios. For that, I have taken a sample beam. All the dimensions are provided in mm. In this beam we have 3 rebars at the top and 3 rebars at the bottom. For the transverse, I have used number 3 rebar, each placed at 125 mm spacing, and for longitudinal rebars I have used number 5 rebars. So these are the cross-section area of number 3 and number 5 rebar. Let's calculate the longitudinal bottom reinforcement ratio. So it's calculated by dividing the total area provided by the product of the width and the effective depth. So since we have 3 rebars, it would be 3 times 200 divided by width is 200 and our effective depth is 600 minus 50, so it would be 550. That would give us 0.00545. These are the units of the input parameters that we need to use. So for longitudinal reinforcement and other reinforcement ratio, we need the values in percentage. So let's calculate the values in percentage. It would be times 100. It would be 0.55 percentage. And for longitudinal reinforcements, is the same method we use. Here I have used same number bars, same number 5D bars at the top and the bottom, and these are there are also same numbers and same size, number 5 rebars and 3 rebars both at the top and bottom. So the longitudinal reinforcement would be same. 3 times 200 divided by the width is 200 times effective depth is 600 minus 50, so it would be 550. It's the same value 0.00545, which would give us 0.55 percentage. And for transverse reinforcement, is the total amount of area steel So a total area of steel provided, it's 2 times 71 for 2-legged stirrup. If it was 4-legged, it would be 4 times 71. Here it's 2 times 71 for 2-legged stirrup. That will be total area of steel provided, and spacing is 125. The width beam is 200. So that would give 0.00568. We need the value in percentage, multiply by 100. That would be 0.57 percentage. That's the value we'll use here. 0.55, 55 and 0.57. So once the values are all provided here, we need to make sure these values are within the valid ranges provided here. That does with by this range check section here, it makes sure the values are within the ranges. And once this is done, we can click this calculate button here, and our output will be provided in this green cell. This is our nominal shear strength. We need to multiply this value with the strength reduction factor to get the factor shear strength. Here I have used this shear strength to calculate the maximum point load the beam can sustain. This calculated maximum point load value should be compared with the factor loads when performing design or safety assessments. So yeah, that's how simple this ANN-ConDeep is to predict the shear strength of two-span continuous steel beams. That's it from me today. I hope you like this video. Thank you very much for your attention, and don't forget to subscribe our channel. Bye bye.